The skill today, if I can pull it up here, is can you solve a quadratic using all methods? Now, when you're taking a test or any sort of assessment or something like the ACT, they're not going to tell you solve every method. So you don't have to know how to solve every method, by every method for the test, but I want you to see different methods so that you could pick which method works for you. So we're going to basically get the same answer 5 different times today. And I just want you to know that all of them are fine to use. Solve them by graphing sometimes does not get you the exact solution that you want. So if you are looking for exact solutions, I would say graphing is not the best choice. So I have some notes out here. They're on the page. Here are some of the methods. One of the methods is to solve by factoring. It's personally my favorite. I think it is the easiest. However, everything doesn't factor. Principles of square roots. The only time you can really use this is if you have a square and a constant. And so that would be when you're missing the x term. So if you're missing the x term, then you can use square roots. And you can see basically you just move the 16 over, take the square root of both sides. So it's pretty simple. Completing the square, I'm not sure I will have enough time to show you that method, but here are some notes over completing the square. I never use this method. I don't find it very efficient. This method is good if you want to find, say, like the vertex, which would be the bottom of the parabola or the top of the parabola. But if all you want is the solutions, then I don't recommend completing the square. But I may try to show you one here or there. And if you get lost, just know that most people don't solve by completing the square. And all the steps are there. Essentially, you look for 6, you divide 6 divided by 2, you get 3. You take 3 squared 9, and then this makes what's called a perfect square trinomial, and I can factor it in x plus 3, which is x plus 3 squared, and then I could square root both sides and then solve for x. So this method, especially on the more difficult problems, I probably won't show. And then, of course, the quadratic formula. The quadratic formula always works for a quadratic. I think it's a good method to use. So let's go ahead and get started. And in your homework, you're going to be given one problem. You're going to be asked to solve it multiple times. There we go. We got our problem. What number squared plus 7 times what number plus 15 is 5? And before I go any further, almost always you want this in standard form. So the standard form would be to minus 5 from both sides. Then you'd get x squared plus 7x. And if you subtract 5 from both sides, you get plus 10 equals 0. So on your practice, just do your best to complete the square. Just try it. All I want to see is just effort there. But when I see a problem like this, I immediately think, let's go factor it. And the reason why I think let's go factor it is because A is 1, and those are easy. So what 2 numbers multiply to 10 but add to 7? That's 5 and 2. Okay, so I'll go ahead and show the work, of course. So the most efficient method, I think, in this case, is solving by factoring. So you'd say, okay, what multiplies to 10, adds to 7? That would be 5 and 2. So you get x plus 5, x plus 2. And then using the zero product property, I would get x is negative 5, and I'll show all my work. So I'd get x is -5 or x is -2. So I personally, like, this is the method I would use. You could also solve by graphing. And for graphing, since we all don't have a TI-83, I am just going to type it into Desmos. X squared plus 7x plus 10. Go look. -2, -5. Okay. So if I'm going to draw a rough sketch, and I know you can't see this right now. So it's going to be -2, -5. And then what's the y-intercept? It's actually going to come up here at 10. And that's a terrible looking parabola. Wish I had an eraser. Ignore that part. So right here at 10 is where it would be the y-intercept. And the way I know it is because the plus 10 there. Okay, so just draw a rough sketch. It doesn't have to be pretty. Now, quadratic formula, this is actually going to take longer to get the answer. And so I'm going to do that like super fast. So I'd write down the formula. There really isn't a good reason to use the quadratic formula for this case, but I would say, okay, x equals -7 plus or minus 7 squared minus 4. A is 1, C is 10. A is still 1. So all I did is I plugged A is 1, B is 7, C is 10 into the quadratic. And then this is 49 minus 40 would be 9. And of course, square root of 9 is 3. And so to get my two solutions, I would first, now you may be asking, why are you adding before you divide? Well, adding is in the numerator, and so they're grouped together, and you always do groupings first. But -7 plus 3 is -4, so I'm doing the plus first. -7 plus 3 is -4, divided by 2 is -2. And then I'm going to do the minus. -7 minus 3 is -10, divided by 2, -5. Okay. So I'm keep getting the same answer. Now solve using square roots. You can't use square roots because it has an x term. You actually cannot solve by using square roots. So in order to solve using square roots, it cannot have a middle term. Now completing the square, I might come back and show this here in a second because I want to show you different problems. Well, actually, I think I remember. We could try it. We could try it. First thing you do is you move the constant over. And again, this method I'm about to show is so confusing. And then you take this number, you divide it by 2, and you square it, so it'd be 7 divided by 2 squared, which is 49/4. So I'm going to add 49/4 to both sides. Now, how did I get 49/4? You always take this number, divide by 2, 7 divided by 2, and then I squared it. 7 squared is 49, 2 squared is 4. So you add that to both sides. Now the reason why you do that is because then this is what we call a perfect square trinomial. And when you're completing the square and this is an odd number, these take a lot longer. So I really wouldn't even do this unless it's an even number. But 49/4 with the 7, this factors into x plus 7/2 squared. And then if I take -10, and I'm just going to use my calculator for that, -10 plus 49/4, and I convert it back to a fraction, I get 9/4. Now, why did this work for factoring? Because 7/2 times 7/2 is 49/4, and 7/2 plus 7/2 is 14/2, which is 7. So if you were to multiply this out, you would get this. So this number is always the square root of this number. Okay, from there, I have a square, so I'm going to square root both sides. So when I square root both sides, it cancels out the square. And then I square root 9/4. And when you do a square root, you always look at the positive and the negative. And the square root of 9/4 is 3/2. The square root of 9 is 3. Square root of 4 is 2. So again, you can see that this method is like, well, why are you doing it this way? And the truth is, nobody really does it this way. Okay. All I want you to, you may not even get the right answer on your practice. I just want you to try. Okay. The most important ones to get are, of course, the factoring and the quadratic formula and the graph. Okay. And then from there, I would minus 7/2 from both sides. I could combine. They have the same denominator. So this would be x equals -7 plus or minus 3 over 2. And then from there, I'd go -7 plus 3. I mean, notice I got the same thing, right? So it's like a fancy way of doing the quadratic formula. So I can jump, I mean, this is the same work. So x equals -2 or x equals -5. Interesting fact, this formula comes from completing the square. And that's why we got the same exact fraction there. So that's where this formula came from, is completing the square. Again, completing the square. The only thing it's really good for is at this step, this is what's called vertex form. And so the vertex, let's see, would be -7/2, -9/4, which is kind of nice. So like if I go back to that graph, -7/2, -9/4 is what I said. See, there's -7/2, -9/4. You see it, -3.5, -2.25. That is -7/2, -9/4. So that's one thing that's kind of nice about completing the square, is it not only tells you the solutions, it also tells you this vertex, which is nice. So some people do prefer completing the square. (9x² = 25). When I see this kind of problem, I automatically think just solve using square roots. Okay, so this is what first comes to my mind because it's missing the x term. So here's how you do square roots. It's actually pretty easy. First, you want x squared by itself. So you're going to divide both sides by 9. And then square root both sides. Well, the square root of 25 is 5, square root of 9 is 3, so I get my answer. Done. Okay. So anytime it's missing the linear x term, x to the 1, this is how I do it. I think it's the most efficient method. Factoring is not too bad. Factoring, you would write this as 9x squared. You would subtract 25 from both sides. And then this is difference of two squares, so that's 3x5, 3x5. So you do 3x plus 5, 3x minus 5. And then you can use the zero product property, set both of those equal to 0. Well, there's negative 5/3. And then I don't really have room to the side, so I'm going to do it down here. 3x minus 5 equals 0. So I would add 5 to both sides. Divide by 3, and I get x is 5/3. Same thing. So you could solve by factoring. Remember, this is called difference of two squares for what I just did. Completing the square, you cannot do. And the reason why is because we don't have an x term, so we can't complete the square. I guess technically you can, but it makes no sense to do it that way at all. Quadratic formula. Let's see. 9x squared minus 25. So I say a is 9, b is 0, c is negative 25. And I'd plug into my formula. Okay. Negative 0 is still 0, same thing. There is no such thing as negative 0. And then 0 squared minus 4 times 9 times negative 25. All over 2 times 9. And then let's see, I don't need the 0. And so when I type in my calculator, 0 squared minus 4 times 9 times negative 25, I get negative 900. I mean positive 900, sorry. And the square root of 900 is 30. And then 30 over 18 reduces to 5/3. You can see you're getting the same result. But if you knew how to do square roots, this is so much faster. But remember, you cannot use square roots unless they're missing the x term. And then finally, solve them by graphing. Let's see. I go type it in. 9x squared minus 25, and I get my solutions. Negative 1.667 and 1.667. And I'm not going to mess with drawing the graph. So what is wrong with doing it that way? Well, 5/3. I mean, this is rounding. Okay, it does not cross at 1.667. It crosses at approximately 1.667. So if you want an exact solution, you should not use graphing, because the exact solution is 5/3. And 5/3 as a decimal is 1.66666666666 repeating. So the 7 actually rounds up, and so that's why it's good to know how to do exact methods, because it's not really 1.667. That's an estimation. It's actually 5/3, and this is actually negative 5/3. All right. Excuse my handwriting, I changed the problem. Let's go, whenever I see a problem like this, when a is 1, I try to solve by factor. So let's go do that. Okay, what multiplies to 1 but adds to negative 4? Multiply to 1? The only thing that multiplies to 1 is 1. And the biggest number you could get would be 2, because 1 plus 1 is 2. So there is no way to multiply to 1 and add to negative 4. So you cannot solve this by factoring. This does not factor. So you can't solve it that way. Also, it has an x term, so you cannot solve using square roots. And I could tell you, if it doesn't factor, then you're not going to get the exact solutions by graphing. It's just not going to happen. So now, really, the only two good methods to use is quadratic formula and completing the square to get the exact solutions. Me personally, I prefer quadratic formula, so I'll do that real fast. So a is 1, b is negative 4, c is 1. And then I plug into my formula. Well, first, write down your formula. So negative 4 would be 4. And then you have negative 4 squared. And then a is 1 and c is 1. I'm going to be lazy and, well, I could do this in my head. That's 16 minus 4. Let's see, 16 minus 4 is 12, so that'd be the square root of 12. And then square root of 12 reduces. I could write that as 4 times 3. And then, of course, the square root of 4 is 2, so I could bring out the 4. I could take the square root of the 4, but leave the 3. So square root of 4 is 2. So the 2 will come out here, 3 stay inside. And then they're all divisible by 2. So I divide them all by 2. I get 2 plus or minus 1 square root of 3 divided by 1. And you don't need to divide by 1. Like that is as exact as it gets. You don't technically need the 1. So I'm just curious what that is in decimal form. So if I take 2 plus square root of 3, I get approximately 3.73. And if I take 2 minus square root of 3, I get 0.267. Okay, this is the exact solution. These are the approximate solutions. Depending on what you're doing, sometimes approximate's okay. Let's go look at the graph, and I'm going to show you that it crosses at approximately 3.73 and approximately 0.267, but not exactly. So I have x squared minus 4x plus 1. Go look at my solutions. Look, there's 0.268. I put down 0.267. So you can already see a problem there. And this one's 3.732. I put down 3.73. So again, these are not exact values, and that's why graphing isn't always the best method. I probably have time to just show this by completing the square real fast. And again, completing the square is kind of tricky. You know, if you really don't like it, I'm okay with you skipping this column, but I encourage you to at least try and see if you can do it. So here's how you would complete the square. You would bring the 1 over, make it -1. So you bring the constant over. You take this number, you divide it by 2. So -4 divided by 2 is -2. And then you square it, so you get 4. So you're going to add 4 to both sides. Now this factors into, it's a perfect square trinomial. It's going to be x minus 2 times x minus 2. And then I'm actually about to show you that in this case, solving by completing the square is actually the best. Then I would take the square root of both sides. And then add 2. And wow, in fact, in this problem, completing the square was actually easier. So that's why it's good to know sometimes completing the square, but most times all the other methods are faster. Okay. The trick to completing the square is to take this number, divide by 2, square it, add it to both sides, because you can't just add it to one side, you have to add it to both sides, and then knowing how to factor this. So -2 times -2 is 4, and -2 plus -2 is -4. So in this case, solving by completing the square was nice. And then I also know the vertex. The vertex is 2, 3. So the vertex of this is 2, 3, which is nice to know. See? 2, 3 right there. I guess I meant to say 2, -3. Sorry, 2, -3. All right, well, that's all I have time for today. In your practice, you're given 3 problems. All I ask is that you try to solve it every method. And on your graphs, feel free to use Desmos. And hope you have a great rest of your day, and I'll see you next week. Bye-bye.